This is Unit 2, Lesson F, Part 1, Rates, Ratios, Percentages, and Proportions. Your objective for today is I can apply rates, ratios, percentages, and proportional relationships. We have three key terms for you today. Your first key term is ratio, and this demonstrates the relative size of two or more values. It can be written with two numbers separated by a colon, or it can be written in fraction form. If you look, this is read 3:4 or 7:8. A proportion now takes those ratios and shows that two of them are equal. So for example, we can say 2/4 or 2/4 is equal to 1/2 or 1/2. Finally, we should have this term down already, but we do want to review it, cross multiplication. Remember, all that is we're taking an equation in the form a over b equals c over d, and we can multiply across to end up with a times d equal to b times c. This skill is going to be used to help us solve proportions today. So if we take a look, we want to start off with a couple review problems because it may have been a while since you've done some cross multiplication. So if we look at part A, we have our first example. 3/4 equals x over 8. We want to solve for x. So what we want to do is we want to cross multiply. So what I do is I multiply through the diagonals. So in this case, I'm going to take 4 times x, which gives me 4x. And that's going to be equal to my other cross multiplication, which will be 3 times 8, which gives me 24. Now you guys should recognize this as a nice one-step equation to solve. So to solve for x, we have to divide both sides by 4, and x is equal to 6. Once again, this should be review for you, but just wanted to refresh it with you guys. If you look at part B, here we have a negative out in front of the fraction. Remember, when there is a negative ratio, what we can do is we can pick if we want the numerator to be negative or the denominator. I'm going to choose my numerator. So when I go ahead and when I do my first cross multiplication, I'm going to treat this as negative x times 3, which we know is negative 3x. And that is going to be equal to what we have over here, which is 6 times 2, or 12. Then once again, we just have a one-step equation to solve. Divide both sides by negative 3, so x is equal to negative 4. Once again, that should be reviewed for you. If we take a look at example 1, so now that we reviewed that skill, we're going to get into everyone's favorite, some more word problems. What we have here is it takes 9 cups of flour to bake 16 dozen cookies. How many cups of flour are needed to bake 72 dozen cookies? So first of all, we're going to go ahead and define our variable. X is going to be equal to the number of cups of flour that we need to bake 72 dozen cookies. We need to set up a proportion. We know in our first ratio, we have 9 cups to every 16 dozen cookies. So my first ratio is going to be 9 to 16. We now can set up a proportion and know that this must be equal to the number of cups we're looking for, which we don't know is x, over the number of dozen cookies we need to bake. So in this case, 72. Now it looks just like the two problems we reviewed. You guys should already know this. We have to go ahead and take 16 times x, which would give me 16x. Set that equal to 9 times 72, which gives you 648. Now, once again, we just have a nice one-step equation. To get x by itself, we divide both sides by 16. So x is equal to 40.5. Now remember, you do not stop there. We need to make sure we answer our question completely. How many cups of flour are needed to bake 72 dozen cookies? We know that when we talk about cups in baking, we don't say 40.5. Instead, what we should do is write this as we would need 40 and 1/2 cups of flour. Do not leave that as a decimal. We need to make sure we're answering the question in context of the problem. All right, so let's go ahead and take a look at example 2. This one is a little bit trickier. We have a lot going on here. If you look, the table below shows your class's results of a survey in which students were asked to name which subject they signed up for table time. It looks like 7 students signed up for English, 10 for science, 20 for math, and 5 for social studies. There are 2,100 students at your school. Write a proportion that you can use to predict the number of students that will sign up for math, then solve the proportion. So if you look here, this question is actually asking us to do 2 things. First, we have to write the proportion, then we need to solve the proportion. What you should notice too is this word, we're looking at math, students that will sign up for math. So that's going to come into play when we set up our proportion. So let's go ahead. We want to start with our table. So once again, when we set up our proportion, we know we are going to have 2 ratios equal to one another. So we can start there. We know already that given this survey, so far 20 students have signed up for math. So in our numerator, we are going to have 20. That's the number of students that have signed up for math based on this survey. Now we need the number of students that signed up for math over the total number of students. So here we have number that signed up for math, and then underneath in our denominator, that's going to be the total number that were surveyed. So in this case, what we have to do is we have to take 7 plus 10 plus 20 plus 5. When we add all those together, we find out that 42 students were surveyed. So that's going to be the number in my denominator. Now we move to the situation that they gave us. There are 2,100 students at your school. That is a total. So 2,100 is going to go in your denominator. It needs to match up. Total in the denominator of your first ratio needs to have the total in the denominator of your second ratio. Now we need to know how many students will sign up for math. So that's going to be X. So X is going to equal our number of students that actually signed up for math. Number of math students. There's part 1. It asked us to set up the proportion. We did that. But now we actually want to go through and solve. So we need to cross multiply. We have 42 times X, which gives me 42X, equals 20 times 2,100, which gives me 42,000. Now, once again, it's just a one-step equation. So we divide both sides by 42, and we get X is equal to 1,000. So what does this tell us? This tells us that 1,000 students signed up for math, or will sign up for math, based on this survey. And we have one more example for today. What we have is example 3, and this is once again one of those nice identify the error type problems. You guys should be getting used to these by now. Once again, we have to do 3 things: identify, describe, and correct. So there's 3 parts to this problem. We have x plus 1 over 6 equals 2 over 4. Step 1, it looks like they took 4 times x plus 1. But we know, you guys should be thinking to yourself right now, when we go ahead and work out this cross multiplication, we would have 4 times the quantity x plus 1 equals 12. If you notice, in step 1, they only took 4 and multiplied it by x. But you guys should be saying right now, wait a minute, we need to distribute. That should be 4x plus 4 equals 12. So you would identify the error by starting off and circling step 1. They made their mistake right off the bat. Now we want to go ahead and describe what happened. So off to the side here, you should say something about they did not distribute correctly. They did not distribute correctly. But then don't forget, we only have parts 1 and 2 down now. We need to continue and solve. We need to correct it completely. So now we have a nice 2-step equation where we would subtract 4 from both sides. So 4x is going to equal 8. Divide both sides by 4. so x equals 2. You have completely answered the question. We picked out the error, identified it, described it, and corrected it by solving it the right way. Don't forget to fill out your bottom portion. We'll leave the U-tries for class. After watching this video, what can you do? What do you still not know how to do? And what are you going to do to help yourself?